Hey, this is Tommy, and this is my demo for the final for Game575. So here's my test folder inside of my Milestone 2 folder, and you can see I have the FBX animation converter.exe, my Lou exe, and vodka exe, and I do have a script that will convert both the animation files that I want, which would be the humanoid and the teddy. So take a look at that script where I'm going to be calling the actual FBX animation converter, the file for the FBX. So I have the teddy and the humanoid, and I'm piping them both into text files just so I could check the data, make sure everything looks okay. And then the second thing I'm going to do is call the vodkas. So I'm going to vodka the hierarchy data and name it hierarchy. They're all type animation type. Then I get the animations, which is going to be my overall header for animations, which will have the number of bones and things. And then animation data is going to have all the actual bone data that I'm going to use in the engine. And I use Lou to create my .tdats, which is going to be used in the engine itself when I read them in with eat. So we're going to go ahead and run that script. And it's going to do teddy first, and it's going to do the humanoid. And you can see the TDATs are being generated. So there's Teddy. Now it's on to the humanoid, which takes a little bit longer. He's got more bones and a lot more frames for the animations in there. So Teddy has the two animations for walk and idle, while humanoid's going to have run, punch, and shot. So now I have these, and I can take both of these TDATs and I can go into my engine and drop them into source. So if we go take a look at the engine, we can go to the game. So I'm creating them, and I'm taking the actual TDAT files and putting them into the objects. So with this, I have created a interface abstract class of sorts where it's called animation object or anim object, and it's going to have a lot of the stuff that we need and all the data. But because there are differences in setting the animation hierarchy and setting the animation data, I've made these pure virtuals, and then I've made two classes that extend this, which are going to be the humanoid, where he has his own, and Teddy. So if we go back to game, when I create these, we go in, and first thing that's going to be different is bone width and number of bones. So we're going to go through and make the pyramid model, make the shader, just like we were doing before. But now I'm going to be reading everything in from my custom format.tdat, and I'm going to use eat to do that. So we go and get the number of bones, and we're going to loop through, and we're going to set everything that we need to set. So we'll get the new graphics objects in there and the game animation objects for each bone using this table, which is hierarchy data that I've made, that's going to have the index of the bone, the name of the bone, and the parent index of the bone. So we use that to set their index and get their parent, which I've made find by name the parent. So once the parent is in the game object manager, which would, for example, be added here, I can go get the parent by the parent's index name and assign the correct parent. And we set up the first bone, and then we go on to the animation data. That's going to also use eat, and we get the general animation header, which is going to be called animations, and just has num bones and the number of animations. So for example, Teddy has the 2 and humanoid has 3. So once we have that in here, we can loop through to the correct number, and I use the buffer and some pointer manipulation to do so. So I have some frame bucket pointers and animation header pointers. So I'm going to create new frame buckets for the result frames, and then I'm going to get their key time and make their bone array, and then get the data out from the buffer, move the pointer to get the next bone, correct the links, set everything up, move the pointers again, and go up and do it all over again until I've gone through every animation and every frame and every bone for each animation file. And then I set up the frame head, and the game rigid objects also need to know what frame or animation stack they're looking at. So if I have 3 different animations, that means I potentially have 3 different frame buckets that are like that, acting as 3 different heads depending on which animation I want. So I've created a method that's going to actually loop through and push the frame head to all of those objects that need it, or I'm sorry, the game animation objects that need it, so they know who they're working with. Once that's in place, we go through the normal steps of going back to animation object, where I can change animations now, process the animation, everything gets called within the update. So I'm going to process the animation data, then I'm going to set the animation pose, set the bone pose, and be able to loop through the animation. And then to clean it up a little bit, I also made an animation manager, which works similar to how my texture manager works, and I've made animation node link instead of using PCS tree and PCS nodes. I just made a basic linear linked list. That way I can add them in, I can change their animations, and I can call update on whoever I need to, and it'll just work. It's pretty clean. I like how it turned out. So the animation manager will always add to the front, and we'll have the link list set up so I can actually loop through just like Game Object Manager or anything would, and update anything that's currently in the manager. This is also singleton. So if we go back to game.cpp, you can see here I'm using those TDATs, so that file name goes in, eat is called, and first hierarchy data will be set, and then the actual animation data will be set for each object, which they're going to have different things like Teddy. I'm not drawing a few of the bones and things of that nature. They're rotated differently so they can appear on screen correctly. And then the update, I've also set up the input manager to get the keyboard and be able to do a couple controls on them, so I can switch their animation stack that they're using. I can speed them up, slow them down, make them go forwards and backwards, and pause them as well. So let's take a look at that. I've also set them different colors just in case. So here we have the Teddy at idle. I can speed him up at idle if I really want to. All right, go back to slowing him down. Super slow-mo. I can change him into a hard set walk. I just have it quick changing. It's not blending. It's just switching which animation stack frame it's actually looking at. So now we're on the walk one. If we go to the other camera, we can see the humanoid is currently in the punch animation. So you can also see the Teddy off to the right. I can pause them. I can continue them forward. I can also make them go in reverse, speed them up, make them go backwards and forwards. I can still kind of use my cameras a little bit, and I can switch the humanoid. So now he's running, and I can speed him up, slow him down, make him go backwards, speed him up backwards, pause him, switch animations. So the way that the animation objects work, I think turned out really well, to have them work almost as an interface and have them do different things, because clearly they have different amount of bones, and the animation data is going to be varying a lot between them. Humanoid has a significantly larger amount of data than the Teddy, including the fact that he has 3 animation stacks than the Teddy. The Teddy only has the 2. I can still switch between the cameras and rotate around the Teddy, and all the controls seem to be working just fine. I think I'm going to clean this up a little bit more and move some of the controls over to the manager instead of having it independent on each one. I just thought it was cleaner for the demo to be able to do it on each one independently.